last video, we talked about the exit function of our IO library and a little bit about system calls and how they work with X86 assembly. And moving forward, I'm going to be talking about the string length and the print string functions that we have to do in our project. So let's get into it. This is going to be a video more about programming. Not going to explain too much. Of course, I'm going to be explaining all the directives, all the instructions that I'm going to be using and why, since we can get a clear understanding, and this can be a great journey for everyone, even those that are getting into assembly like right now. So let's get into it. So now we're going to be looking at the string length function. The definition of it is a function that accepts a pointer to a string and it's going to return the length of the string, basically a strlen. And for us to do that, we need to have a clear understanding of how we define a function in assembly. So let's get to our workspace. So right here in our workspace, as you can see, I wrote a little makefile. This makefile is going to be helping me assemble, so I don't have to type like 2-3 commands. It's going to be way faster. It's very good. I love makefiles. That's it. So if we go here into our program, as we can see, is in the same state as in the last video. And the first thing we gotta do is create a new section called data section. And in assembly programs, the data section contains variables and constants that are gonna be using alongside the program. So let us create this function at the top of the file. And now, since I'm going to create a test string, I want to firstly add a label to it. So it would be like test string. I'm going to put test stir. And after this label, I'm going to be using a directive called db, which is define bytes. It's going to define a stream of bytes or even just 1 byte for me to work on. So we add db and the stream of bytes as characters, since even in C, that's how strings are represented. It's a stream of characters. In assembly, it's the same way. So we define here, let's say this is a test string. This is going to be our little string. And now we're going to pass a second parameter, which is a number. This number is going to be 0 because there's something called null termination. So this 0 is a null terminator, as I said before. And in many programming languages like C, the strings have to be terminated with a null byte, in this case a 0. And this is done to mark the end of the string. So the function that is processing that string knows where the string actually ends and doesn't keep looking for more characters to consume. And now we have our test string. So this test string is a string of length 21. I'm actually even going to write it here. So we can remember. And a good thing to mention as well is that in a real life scenario, when we actually finish our library, we're not going to have anything under this the data section, since this library is solely to be used in a dynamic way. So everything that we type in the standard input or receive via keyboard is going to be actually inserted into the library. So everything is going to be dynamic, and there's no need for the data section at this moment. This is merely a test for us to visualize. Now we're going to write our string length function, and this function goes on the text section. So we write a label to it, and the way that we're going to determine the length of a string is basically iterating through the string until we find the null terminator. Then we'll know the string actually ends. So for example, on the start function, I'm gonna tell the assembly that I'm gonna store, I'm gonna move the to the RDI register what we have in our label test string. So basically this says that this sets a pointer to the beginning of the string, to the beginning of, in this case, t, the first byte of the string, until the null terminator, saying that we are pointing with RDI to the beginning of that string. This is basically what I'm doing right here. So let us focus right now on the body of the function. The first thing we gotta do is define what register we're gonna be using to increment the value of the length. And for that, I'm gonna be using RAX. But the first thing we gotta do is zero out RAX register, because we never know what data might be in RAX. Since it's been uninitialized, it can be garbage. So incrementing garbage will lead to more garbage and the value will be incorrect. So a good way for us to fix this is by doing a simple instruction called XOR. XOR. And XOR basically is for exclusive OR, where if you have the same output, it would output the same input for two values, it will output 0. And if those values are different, it will output 1. Here's the truth table to it. I'm going to be putting right above me, so you can have a little bit of an idea what I'm talking about. So this, if I do RAX and RAX to XOR, since it's the same value, it will zero out. So that's what we're going to do to make sure that RAX contains the value 0. And now we need to loop. We need to add a loop to our function. And for us to do that, we can create a dot loop function inside the string length. So this basically says that inside the string length, we have a section. We define that it is a section from the string length by this dot in the beginning. So dot loop belongs to string length. And now we're gonna do a comparison. So we're gonna do the CMP instruction, which is compare. It receives two values. The first value is the value we are comparing, and the second value, the second parameter, is the value that we are comparing the first one to. So for that, I'm gonna put byte. This basically says that I'm looking byte for byte, not in a big manner. For example, if I pass here only RDI, it will look into the whole string, and that's not what we want to do. We actually want to iterate byte from byte, right? So we add this byte to RDI plus RAX. Why do we do that? Well, since RAX is 0, in the first iteration it won't change. But since we're gonna increment RAX every time until we find the null terminator, this will help us move through the string. And we're gonna compare this to 0, because when it's 0, we're gonna quit because we already found our value, right? Okay, so let's put here JE, which is jump equal, basically saying that if the byte in RDI plus rex is 0, we're gonna jump to another label that I'm gonna put here called end, dot end, and this dot end basically is gonna return, and we're gonna be talking about it just in a second. I'm not gonna be doing it right now. Let us finish the loop logic. So after that, we increment with the inc instruction the RAX. If we don't pass any value to the second parameter of inc, it assumes that we're incrementing one by one. So that's what we're gonna be doing right now. We're not gonna pass any second parameters because we actually want that one by one incrementation. And after that, we're gonna jump to the beginning of the loop again. since there's still characters for us to process, and it didn't jump to the end of the function. So now working on the AND body, we're just gonna put a simple instruction called ret. This directive tells us that whenever we call a function, the value that needs to be returned. So this value will always be placed on RAX. That's why I chose RAX to be incremented. Since it's a function that we need to call, we're gonna use it later on. Make sense? I hope so. So well, now if we come here to the start, we can think as of RDI as a register that has the string. So we can call the string length and expect the result. Remember, the result will be an RAX. So we can actually see the value of our string length by printing the value on exit. Since we don't have an print unsigned integer right now, we cannot print integers, but we can see as the return code of an exit function, for example. So let's do this little trick. And right now the value of RDI is the test string, so we're gonna pass the value of REX, which is the length, to RDI. So let's move RDI to RDX, move the value of RDX to RDI, and then we're gonna jump exit, and exit is basically gonna move 60 to Rex, saying I'm gonna do an exit system call as we saw in the previous video, and is gonna print out the length of the string, which should be 21. So let's compile this and try it out. I noticed a little bit of error. So we're gonna make all. It does the thing for me. And now we're just gonna IO_lib. And it outputs 21 as expected. Simple as that. Perfect. That's about it. See ya.